Okay, this is for decomposing equations with proper rationals where Q only has non-repeated linear factors. And there's 4 cases. This is case 1. And when I looked through the book, I found all of these. So probably this will be 2 videos, but I just don't know when I'll stop. I'll probably stop after 20 minutes and then finish them up. You will have a quiz on these. And so we first want to talk about what non-repeated linear factors are. You should have watched the previous video to this. That was 5 through 12 because I talked about why we're doing this. I'll talk about it when we first do the first problem, but after that we'll just continue on. So basically you get a rational expression as such. And we want to decompose it by taking these linear factors here. And notice they call them linear factors because this is a linear term, x is a linear term, and so is x minus 1 is a linear term. So what we're going to do is figure out how they got this. So we're going to split it apart, and the way we're going to do this, we're going to put an a over x and a b over x minus 1 because we're looking for a and b. Okay, and then we'll go back and I'll explain again why we're doing this if you didn't watch that other video. Now what I'm going to do from here is clear the denominator. So by doing that, what I'm doing is multiplying by my LCD. My LCD is the least common denominator, which in this case is x times x minus 1. Now we're multiplying this by 3 pieces. We're multiplying it by the first, and by this term, and by this. So when you multiply it by the 4 over x times x minus 1, it cancels and you just get 4. When you multiply it by a over x, you're just going to get a times x minus 1. And when you multiply it by b, this part will cancel and you're just left with x. So you have bx. Now keep in mind we're trying to solve for b and a. Now what you can do is, first of all, we can just say, well, let's let x be, because x can be anything and you can solve. Let's let x be 1. If x is 1, what happens? Well, then we have 4 equals a times 1 minus 1 plus b times 1. And you get 4 equals 0a plus b. So b equals 4. Okay, so we already know that right up here b is what? 4. Now let's check for a. To check for a, let's let x equal 0. So when x is 0, we get 4 equals a times negative 1 plus b times 0, which is just 0. So negative a equals 4, so a is negative 4. So a is negative 4. Now basically what I said before is what they're doing is, if you have negative 4 over x plus 4 over x minus 1, and you find your common denominator, in essence in this case would be cross multiplying, and you clean this up, you get negative 4x plus 4 minus 4x over our LCD. And these two cancel, and we're left with 4 over x times x minus 1. So basically we're working backwards. So now we came back to our original equation. So they're giving it to you this way, and we have to break it down here. So this is our final answer is this. Negative 4 over x plus 4 over x minus 1. We just decomposed this rational expression. Okay, now we're going to, Now that's the y. Now we're just going to do some problems. The next one that I found that was non-repeated linear is 14. So 14 we have 3x over x plus 2, x minus 1. So we need to find out how to decompose this. Now, when they're saying non-repeated linear, all they're saying is there's no square here. This would be a repeated linear, and we'll be doing that in another video. So basically, all I'm going to do is I have to find out what my numerators were originally. So I'm going to put x plus 2 plus b, x minus 1. And we're just trying to find out what was the original numerator here. We already know what our LCD is, because our LCD is right here. So we're going to clear our fractions by multiplying by the LCD. And we multiply it 3 times. We're going to multiply it by this part. 1, 2, 3. So we multiply the first part. This will cancel out, and you just get 3x. And then here we're going to have a times x minus 1 plus b times x plus 2. Now what I'm going to pick, I'm going to let x be 1, because that will zero out my a here. If I let x be 1, what happens here? I get a 0 here, and then I can solve for b. So everywhere there's an x, I'm going to put 1. It's going to be a times 0 plus b times 3. So we get 3 equals 3b. So clearly b equals 1. Okay? And then to knock out my b, this is where we let x equal 1. To knock out my b here, I'm going to go ahead and let x be negative 2. So when you let x be negative 2, you're going to get 3 times negative 2 equals a times negative 2 minus 1 plus b times 0. So that's what we wanted. We wanted to knock out the b so we could solve for a. That's why I let it be negative 2. So we get negative 6 equals negative 3a, so a equals 2. And then all you have to do is come back up here, and I'm sorry I even kind of did this, clean that up a little. And my b is 1, so my b is going to be what? 1. And my a was what? 2. So if you were to combine these with getting the common denominator, you would get this. But this is our answer. Okay. Now, the next one's going to be 17. This book mixes everything up. So we have 17, which is x over x minus 1, x minus 2. The reason these are non-repeated because they're different. They're not the same. So we're just going to write this as, and it's a proper because the degree in the numerator is less than degree in the denominator. X minus 1 plus b over x minus 2. I'm going to clear the fractions by multiplying by the LCD, which is x minus 1 times x minus 2. And what's going to happen is this part cancels out. So you get x equals a times x minus 2 plus b times x minus 1. Now, the first thing is if we want to get rid of the a, we're going to let x be 2. In that case, the a will cancel because you have a times 0 plus b times 1. So you get b equals 2. So I'll just put b equal 2 here. And now we're going to let x be 1. So I'll let x be 1. That will clear out the b. So everywhere there's an x, I put 1. And the b cancels out here because this is zeros. The zeros cancel. So you get negative a equals 1. So a equals negative 1. So a is negative 1. and you have your answer here. And that's all you're doing. Okay, the next one is 18. I'm going to go up to 20 minutes on this. If you kind of got it, you can probably stop now and start trying to do some without looking. Of course, we'll be doing these in class. These are just extra practice because you're going to have a quiz on this. This is very important for calculus, by the way. So we have 3x over x plus 2 times x minus 4. So we're just going to set this to a over x plus 2 plus b over x minus 4, and clear the denominator, or clear the fractions. So we multiply by x plus 2. Let me erase this. This is 18. I'm just going to put it on this side. I don't like it on that side anyway. So we're going to do x plus 2 times x minus 4, and we're just multiplying it by each term so that it cancels here. So we get 3x equals, in this case, this will cancel with that. So you just have a times x minus 4 plus b times x plus 2. So now what are you going to do? We're going to let x be what? Let's let x be 4. If we let x be 4, we're going to get 3 times 4 equals a times 0 plus b times 6, or 6b. So that yields 12 equals 6b. So b is 2. So I can change this. Let me erase some of this. B is 2. And if I let x be negative 2, so we're going to let x be negative 2, we're going to get, that's for the second part, we're going to get negative 6 equals negative 6a plus 0b. So a is going to be 1. Let's divide by negative 6 on both sides, so a is 1. And that's as simple as it gets. Let's do 31. Let's see why that one is way down there. 31. Maybe I can get all these done in 20 minutes. 31. Okay, 31. Oh, the only thing different with 31 is they made the denominator a little more complex, so who cares? We have 2x plus 1. So we're going to set this to a. These are still non-repeated linear factors. We get 3x minus 2 plus b times 2x plus 1. Now, to clear this, we're going to multiply by the LCD, which is 3x minus 2 times, just know this is times, 2x plus 1. So we know this will cancel, and you get x equals, and basically you're just cross-multiplying a little bit. It's not actually cross-multiplying, but basically what you're doing on these. 2x plus 1 plus b times 3x minus 2. Okay? So on this one, which one is this one? This is 31. So what we can do is we can let x be negative 1/2. If we do that, we know this goes away. The a goes away, so, okay, I'll just write it out. 2 times negative 1/2 plus 1 plus b times 3 times negative 1/2 minus 2. That yields negative 1/2 equals 0a. That cancels, so it's negative 1 plus 1. And here we get b is going to be negative 7/2 b. And so when you solve for b, we're going to multiply both sides, I'm doing a different color, by negative 2 over 7. And that's going to cancel here. So you're going to get 2 negatives cancel as well. So 1/7 equals b. Now what we're going to do on this, we're just going to go ahead and put the 1/7 on top. We're not going to worry about putting the 7 down here. Don't put it here. Just leave it on top like that. Alright? Now let's do the let x be 2/3 or negative 2/3. Yes, 2/3. So we have 2/3 equals a times 2 times 2/3 plus 1 plus b times 3 times 2/3 minus 2. This will cancel. So basically we get 2/3 equals 7/3a. Multiply both sides by 3/7. So that will cancel there. That cancels. So you get a equals 2/7. So then you go back here, and a is what? 2/7. Alright. And that one was what? 31. Okay. I think I'll let you do 32 on your own. It's the same principle. 33 is pretty much the same. Let's look at 34. 34 is a little different, so let's do 34. And the rest are basically the same. So let's see how far I can go with this. So we're going to do 34. 34 basically, a little different. We have x squared minus x minus 8 over x plus 1 times x plus 2 times x plus 3. I think your book gave it to you this way, x squared plus 5x plus 6. So you're going to have to factor that. So in this case, we're going to have a over x plus 1 plus b over x plus 2 plus c over x plus 3. And now to clear the fractions, basically we're multiplying by our LCD. I'm going to go ahead and erase 34. I'll put 34 right here. This is 34. So we're going to multiply by our LCD, which is, I'm trying to make it small here, x plus 1, x plus 2 times x plus 3. So clearly this will cancel this part. So you're just going to have x squared minus x minus 8. Oh my goodness. Okay. Minus x minus 8 equals, and basically when you cancel out the x plus 1 here on this one, you're left with these two. So you're going to have a times x squared. I'll do this in steps. So this is going to be x plus 2 times x plus 3 plus b times x plus 1 times x plus 3 plus c times x plus 1 times x plus 2. Okay, now on this part here, what I'm going to do is go ahead and FOIL this out, because this is like this. So we're going to say this is a times x squared plus 5x plus 6. This one is b times x squared plus 3x plus, no, it's 4x plus 4x plus 3. And this one's going to be c times x squared plus 3x plus 2. Alright? So basically, this one is 34. We're going to have let's do this. We're going to have x squared, I'm going to try to write small, x squared minus x minus 8 equals, I'm going to go ahead and keep it separate for now, x plus 2 times x plus 3 plus b times x plus 1 x plus 3 plus c times x plus 1 and x plus 2. And basically the first thing we're going to do is go ahead and let x be negative 1. When we let x be negative 1, what happens here is these two right here will go away. Because you're going to have negative 1 plus 1 in both of these. That's going to be 0, and that's going to knock out this whole thing here. It's just going to knock it out. Same with this one. It's going to knock this whole thing out. So we'll find a this way. So negative 1 squared minus a negative 1 minus 8 equals a times negative 1 plus 2 times negative 1 plus 3. So here we're going to get negative 6 equals 2a, so a is negative 3. Okay? Then we're going to try let x equal negative 2. The reason we do that one, it will knock out this one here, and it'll knock out this one. So we'll find b. When you do that, you get negative 2 squared minus a negative 2 minus 8 equals b times negative 2 plus 1 times negative 2 plus 3. And that yields negative 2 equals negative b, so we have b equal 2. Okay? And the next one's going to be let x be negative 3. So if we let x be negative 3, it will knock out these two, and we'll have our c. So let's do that. We're gonna, if we let x be negative 3, then we get negative 3 squared minus a negative 3 minus 8 equals a times negative 3 plus 2 times, oh, we don't want the a. We already know that's going to be knocked out, so I'm trying to save time here. Again, we'll be doing more of these in class. We want the c, so we'll get c times negative 3 plus 1 times negative 3 plus 2. So this yields 4 equals 2c, so c equals 2. And then you write it out, you get x squared minus x minus 8. For some reason I think 8 is x. Alright, over x plus 1 times x squared plus 5x plus 6, and we get that's a is negative 3 over x plus 1 plus b over x plus 2, and b was, our b was 2, plus another 2 for c over x plus 3. And I think that's enough for this. So I'll look at the others. I might do, let me look at 37 real quick. 37 is the same. And the next one I thought was 43 and 44. Let me look at those. 43 and 44. Oh, those are really easy. So, we'll just leave that one for you to do. So you'll be doing those in class. And that's all with non-repeated linear factors for partial decomposition.